Before hashtags, before email, before the word Internet even existed, a single refrigerator-sized computer in a UCLA laboratory quietly carried the first digital conversation across a network. That machine, the Interface Message Processor, or IMP, was the gateway that turned isolated mainframes into a web of shared information. Yet the very device that launched the online age simply vanished. No museum plaque, no shipping manifest, no photograph of it gathering dust in a government storeroom. It helped create a technology that remembers everything, and then disappeared without a trace. The story begins not with computers, but with fear. In October 1957, the Soviet Union startled the world by lofting Sputnik into orbit. For Americans, the beeping sphere wasn't merely a scientific triumph, it was a warning shot that technological surprise could strike at any time. In response, the U.S. Department of Defense created the Advanced Research Projects Agency, ARPA, to fund bold experiments that could keep the nation ahead. By the mid-1960s, ARPA's Information Processing Techniques Office was pouring money into university computing labs. Yet every mainframe was an island. A scientist at Stanford couldn't easily use a program at MIT. Each machine spoke a different language and demanded its own punch cards. Larry Roberts imagined a radical fix, a network where computers shared resources over long distances. Messages would be chopped into tiny packets, each finding its own path through the network before reassembling at the other end. Despite skepticism, ARPA approved the experiment and named it the ARPANET, planning to connect 4 universities: UCLA, Stanford Research Institute, UC Santa Barbara, and the University of Utah. The first node, the one destined to become history's missing artifact, would be built at UCLA's Network Measurement Center. To transform theory into reality, ARPA hired a small Cambridge, Massachusetts firm, Bolt Beranek and Newman, known as BBN. BBN engineers built a rugged, programmable mini-computer to serve as each site's gateway, the Interface Message Processor, or IMP. The IMP was based on the Honeywell DDP-516, a 12-bit workhorse running at a blazing 1 MHz with a massive 12 kilobytes of memory. Encased in a steel cabinet the size of a household refrigerator and weighing nearly 900 pounds, it looked more like industrial machinery than a research computer. UCLA's Network Measurement Center, directed by Leonard Kleinrock, was chosen as the network's first site. Graduate student Charlie Klein and programmer Bill Duvall would send the very first message. They spent days testing modems, checking leased telephone lines, and refining code that would travel 350 miles north to Stanford Research Institute. Late on the evening of October 29, 1969, at 10:30 p.m., Klein typed the command to log in, LOGIN. The system crashed after only 2 letters, LO. Those 2 letters formed the first electronic whisper across a computer network. Minutes later, after a quick reboot, the full login succeeded, and packets of data leapt from Los Angeles to Stanford. Within weeks, 3 more nodes joined the network: UC Santa Barbara, the University of Utah, and Stanford itself. By Christmas of 1969, the ARPANET had become a living system, a small but unprecedented web of computers exchanging data in real time. Graduate students and professors quickly discovered they could share programs and messages instantly, skipping the days or weeks once required to mail punch cards across the country. At the center of this quiet revolution stood the very first IMP, Serial number 1, still humming in UCLA's Boulter Hall. Technicians posed proudly beside its steel frame, unaware they were standing next to a future relic of global importance. The moment the first packets crossed California, a new kind of communication was born. Within days, researchers were sending tiny test messages, debugging code, and dreaming aloud about libraries of information that could be reached from anywhere. Leonard Kleinrock recalled standing in that lab and realizing they had changed how humans would share knowledge forever. But to the rest of the world, it was just another obscure government experiment. By early 1970, the ARPANET leapt beyond its California roots. New nodes sprang up at MIT, Harvard, and the Stanford Artificial Intelligence Laboratory. Researchers could log into distant machines, borrow processing power, and swap data in seconds. For scientists used to mailing reels of tape across the country, this near-instant access felt like magic. Programmers in Boston shared code with colleagues in Utah overnight. Mathematicians ran simulations on machines they had never seen in person. But magic came with chaos. No one had anticipated how quickly students would flood the network with personal notes and jokes. In 1971, Ray Tomlinson, a young engineer at BBN, improvised a side project, a program to send direct messages from one user to another. It was the first email. The network began to reshape academic culture. Ideas that once traveled at the pace of postal mail now spread overnight. Graduate students at distant universities debated algorithms in real time. Physicists shared preprints instantly. Government officials watching from Washington were amazed and uneasy. What had begun as a military experiment was turning into a civilian playground. Some feared uncontrolled communication might leak sensitive data. Yet ARPA's leaders pressed ahead. They saw in this messy, unpredictable network a glimpse of the future. A world where information could be shared without gatekeepers. Amid the excitement, few paid attention to the physical machines themselves. Old IMPs were swapped out for newer models as the network grew. Technicians recycled cabinets, moved them to storerooms, or repurposed them for spare parts. The first IMP, Serial number 1, remained at UCLA until the mid-1970s. When it was finally decommissioned, records of its removal were astonishingly thin. A work order shows it left Boulter Hall, but no shipping slip or receiving log reveals where it went next. Some believe it was hauled to a scrapyard and quietly dismantled for parts. Others suspect it still sits in a government warehouse, its significance overlooked. And a few romantics imagine it locked in a private collection, humming faintly in a forgotten corner. Whatever the truth, the computer that carried the first internet message simply vanished, leaving behind only the network it helped create. By the early 1980s, the ARPANET had blossomed into dozens of nodes and thousands of users. Electronic mail outnumbered all other uses combined. Researchers exchanged datasets, code, and even early jokes, creating the first online communities. The network's success inspired parallel projects worldwide. In France, the Cyclades experiment refined packet switching. In Britain, the National Physical Laboratory built its own test network. Together, these ideas would feed into a grander vision, a single, global internet. Yet the original IMP that started it all was already missing. When historians began looking for it in the 1990s, just as the World Wide Web was exploding, no one could trace its path. Digital archaeologists scoured UCLA's records, the Defense Department's archives, and BBN's corporate files. They found photos of technicians standing proudly beside the cabinet in 1969, but nothing after the mid-70s. Retired engineers recalled that obsolete machines were often stripped for usable parts or quietly scrapped. Some remembered a large gray cabinet leaving Boulter Hall on a flatbed truck, but couldn't say where it went. A few tantalizing leads pointed to surplus auctions around Los Angeles. Old government computers sometimes went to universities, sometimes to private buyers. But no receipt, no crate, no serial plate has ever surfaced. To this day, the first computer to carry an internet packet remains unaccounted for, a mystery in a world built to remember everything. Yet the IMP's disappearance changes nothing about its impact. Every email, every text, every streamed video traces a lineage back to that October night in 1969 when two letters, LO, crossed a single phone line. The engineers who built it never imagined billions of people would one day carry the network in their pockets. But their modest experiment proved that information could flow freely, across any distance, if you trusted the packets to find their way. The computer that started it all may never be found. Perhaps it was dismantled, its circuits recycled, its steel melted into something unrecognizable. Or perhaps it waits silently in a forgotten storeroom, the unmarked ancestor of our digital world. What matters is the network it set in motion, a network that outlived the machine itself and forever changed the way humans connect, create, and remember.